Okay, welcome. We want to look at the balanced forces and unbalanced forces. So in the previous, we looked at the types of forces where we talked of contact forces as well as non-contact forces. So today we'll be looking at the Newton's first law, such that we can really appreciate the issue of forces that are balanced and forces that are unbalanced, right? So the first law of motion is the one which suggests that it says that Newton's first law is also called the law of inertia, right? So it states that any object will remain at rest, right? It will remain at rest, or it will be in uniform motion unless an unbalanced force acts on it. And it is that okay? So something will remain in motion, or it will remain at rest unless an unbalanced force acts on it. And it so this one is an example of something chinoitika kuspace chekuti if a space thing chikara kuspace kusina gravity kusina any other forces, and it if something moves, right, chinongoramba chingori the same speed, chongoramba chingobaya chete until what, until something has to what, has to push it, then it will come to what, to stop. And it iwe dai waiti kuti ukangotry kujamba so waibva waramba uchingoenda mudenga uchingoramba uchingoenda eva vasina gravity and wairamba uchingochaya chete uchingobaya. Is that okay? So the first law of motion, it states that anything remains at rest or a uniform velocity unless what, there is an unbalanced force that acts on it. And so it would also have to allow us to understand kuti chi chinobonzi balanced forces as well, what is what unbalanced forces. So on the first go, on balanced forces, on these balanced forces, if two individual forces acting on an object are equal magnitude and in opposite direction, then these forces are said to be balanced. And it is that okay? So we have this one, and then we have this one, right? Let's say we have force A and force B, and it so force A and force B there are two individual forces that are acting against each other. Let's say we have 10 newtons, and here we also have 10 newtons, right? So if they act against each other, right, they meet a particular point and they are acting against each other, they would create a balance. And it because why, there is no resultant. And so which means that we are pushing a 10, A are pushing a 10, B are pushing a 10, then chinchamba chiramba chikaita chakangomira. Is that okay? Then balanced forces cause an object to be at rest. Is that okay? It causes an object to be at rest, or an object to be stationary, or moving at a constant speed with zero acceleration. Is that okay? So most, they won't understand the concept of an object moving at a constant speed, right? An object can move at a constant speed, which means it can move at the same speed without changing, and it that just remain the same. It is because panenge pane balanced what, forces, and it so zvinenge zviripo zvinongoramba zvingori remaining, and it that's what it does. So we have examples of those. If we have example here, maybe probably a resting book and it on a table. So resting book on a table, we would notice that we have two forces acting on opposite directions, and it pane panambo is like pane panokuisira this, and it can, like I said, this, and it just means that another force is acting going this direction, another force is acting going what, this direction. And it so don't be confused on this part and it as well as what, this one. It's just the same thing. And it so bhuku redu riri patable. Let's say kuti taisa table yedu iyi, and riri patable kudaro, there is a force going downwards, which is what? Weight. And there is a force going upwards, which will be the what? The normal. And it is. And then the normal and the what and the weight are supposed to be equal, such that the book just remains on the table. And it, once we find that the weight yawandisa, it will then have to break the table, and then the object move what? Downwards. And it, we also have the FA, which is that force, as well as what? The FF. And it, so those two will be acting what? Against each other, and then they will cause the what? The book to just remain what? Stationary. And it, so sideways, pane two forces that are being applied. And then the forces acting on the book are said to be balanced, and they will remain at what? At rest. We also have the second example, where an object is moving on a horizontal surface. And it, so we have these two forces. We have FA and FF. They would cancel each other, as they are of equal magnitude, but in the opposite direction. But we would see something that this object would then remain in constant what? Speed. And it is chachagara chiri kumove, but then there is now a force moving ukoko nechi ne against. And it, so it just remains at what? At a constant speed. And it, ndozvo zvakangofanana nezvekuti uyo uri kuenda, uri kufamba, and motikari yako yauri kufamba naye iri kufambira kana kuti speed ye30. Handiti ichifambira muspeed ye30 inongoramba yakadaro, handiti iri mu30 momo, because pane mabalancing forces. Handiti treatise to experience an unbalanced force when a force is acting on the force that is acting on the object is not balanced by another force of equal magnitude in the opposite direction. And it, so at first we were talking about my forces are acting, like let's say for example papa, you have your force which is going at the top, right, and the force which is going downwards, right. So if they are differences within the forces, right, right, ambutaura kuti inenge iri 10 and it on the other, and then it is balanced. Then let's say that this one becomes not 100, we say that this becomes 7. So if this one becomes 7, it has become smaller, and then if it is smaller than the opposite one, then we would say that the object will experience what? An unbalanced force. And the results for unbalanced forces is that we obtain acceleration, and acceleration, which is the change in what? Or the change of speed and all. And it, are we together? So the example there is the one at theta, where we have the force what? A being lesser than the force what? W, and we find something accelerating going to the direction of the force which is greater. Is that okay? And then the second example is of an object that accelerates on the horizontal surface, right? So we have here experiencing a greater force than what? This side. So we have a resultant going this side, and then that resultant will result in an acceleration or a change in what? In speed or velocity. Then after that, we also have to look at the second law of motion. And the second law of motion insists that forces have both the magnitude and direction, as we have said earlier on, that forces are vectors. And then two or more forces acting on an object can be combined into a single force called a what? A resultant. And it, are we together? They can be combined into a force called a what? A resultant. And it, so let's say for example we have two forces, right, which is F1 and F2. they are both going in the same direction, and so if they are going in the same direction, they would add up together, and so we have the force, the resultant force here being equal to the addition of what, of those two, and then if they go in different directions, and it would tend to have what, especially if they are going directions and opposite, takuchibva subtract this from this subtract what, f2, whereby we have the resultant f here will be equal to what, to the force number 1 minus force number 2. So since force is a vector quantity, the positive sign and the negative signs, they all indicate the directions of the forces, and then we have an example, and on the example tapiwa the first one with the same direction, right? We are going to add them, and then they gave us what, 20. Then on the second one, they are on opposite directions, and but they are of equal tracing, and the resultant is what, 0. So if the resultant is 0, it means that it's a what, it's a balanced force, and then we also have 10 and what, and 5. Then we're subtracting, and then we get a resultant of what, of 5 newtons, and but this resultant of 5 newtons, it goes along the direction of where we have the greater force going, and so which means there is a resultant which is supposed to be going in this direction, and are we together? And that resultant will be of a magnitude of what, of 5 newtons, which is the difference between this one and what, and this one, and so when a resultant force acts on an object, the object will accelerate in the same direction of the resultant force, as I was saying earlier on, and saka panapa we have 8 newtons, and we also have 5 newtons, and we have different directions. So the direction of 8 newtons, and we are here to say each end our resultant, and our resultant will be the difference between the two, which is 8 minus what, 5. That gives us what, 3. So when the resultant force is 0, then an object would not move and will be at constant speed or a constant velocity. The second law states that acceleration of an object is directly proportional to the resultant force acting on it and inversely proportional to its mass. So now what they are saying is that the acceleration of an object A will be directly proportional to the resultant force, right? And to the resultant force acting on it, and inversely proportional to its mass. Is that okay? So that's where we come up with what, F is equals to what, is equals to ma. So if we would want to know the party and the inversely proportional to its mass, its acceleration, which is inversely proportional to the what, to the mass. Is that okay? So if we have F is equals to what, ma, then we want to see the relationship yakuti mr will relate say to what, to A, then panapateta kuti F over what, m will be equal to what, to A. Let's say for example we have tabvisa F, we would tend to find that A yedu will be inversely proportional to what, to m. That's what they're trying to say by the statement, right? But Shingosot, the second law of motion, it just states kuti is what, F is equals to ma. So the second law is what, F mat. The second law is what, it's F mat. Are we together? And the first law we are saying kuti an object remains, it remains at constant velocity or remains stationary unless what, there is a force that acts against it. Is that okay? And we say that it's the law of inertia, and so let's look at an example which is worked out. We've worked at example number 1. Then a car has a mass of that and 2.0 times 10 to the power 3, and the resultant force created is what? Is 3 times 10 to the power of what? 3. So we have this one being the mass and this one being the force, and we are asked to calculate the acceleration caused by this force. So having known that the mass and the force are given, tangoti a yedu using the formula trinity a yedu is equals to F over what? M, of which F yedu, that's the force, which is what? Which is 3.0 times 10 to the power 3, which is equivalent to 3000, all over the mass yedu, which is 2 times 10 to the power 3, which is equivalent to what? 2000, and then we get an acceleration of 1.5 meters per second squared. So acceleration is always in what? In meters per second squared. Is that okay? Then to Vatanzi, a man applies a force of 50 newtons to move a carton of mass 10 kg, isn't it? So the force here is what? Is 50 newtons, and then arikumova icarton rine mass yedu yechi ye 10, so m yedu is equals to what? To 10. Then at a constant speed, then answer, what is the frictional force exerted by the floor? Treatise. And what is the frictional force exerted by the floor? And it, so if it is a constant speed, there's something that we have to take note of. The statement runs constant speed. If speed is constant, it means the speed is remaining the same, and it, let's say with the speed yanga iri pa 20, yevha yange iri pa 20, and it, so the change in speed is equal to what? The change in speed will be equal to what? To 0, and it, of which isusu yatiri kuti change in speed ndo iri kunzi acceleration, and saka which means kuti acceleration yedu will be equal to what? To 0. Saka by constant uita vatatoziva kuti a is equals to what? 0. Is that okay? Sure. Saka panapa tine takushandisa formula yedu takunzi F is equals to what? Is equals to ma, and it treatise. So if acceleration is equals to 0, it therefore means that the force itself will be equal to what? 0, because any number panapa tineta kuti m yedu multiplied by 0, it will give us what? It will give us 0, and it, saka takutoziva kuti the resultant force yedu will be equal to what? To 0, and it. So if resultant force is equal to 0, we have an applied force, and it, taita applied force pane pachidawo kuzikanwa kunzi pa applied force apa padawo kuzikanwa kunzi the resultant force tinayo pane applied force popaita a force that is against, and the force that is against the movement is called what? Friction. That's why panapa takuchiuya takuchiti force manje yedu yatatati this F yedu is equals to 0, and it takuti is now equal to what? The force applied. The force applied yedu yangerichi 50 newtons. Subtract iyo what? The frictional force. Saka tadaro takuchibva tangoita simplify, and then frictional force takubva taisa on the other side, and then it becomes what? 50 newtons. Is that okay? So the friction was what? Was 50 newtons. And then we go to the second example. In the following diagrams, calculate the resultant force, and it calculate the resultant force. So the resultant force yepekutanga, it's going sorry, it's not going in that direction, it's going this direction, and it, and the difference between 150 and 100 is what? 50, and it. And then panapa on the second one tine inenge ichienda this direction, and it, and the difference between 35 and 50 is what? Inenge iri 15, and then panapa we find out kuti panapa ne 100 and there is 100, which means kuti it is balanced, and it. Panapa kumsoro we have 50 and then we have 10, so which means it would go what? Upwards. So upwards, the resultant force will be equal to what? 50 minus 10, and then it gives us what? 40 newtons. Is that okay? Then wait. We have those differences, and that's B. I think there's an error here, and it up power 50 newtons up, power 60 up. These two and these two, they are going in different directions, and this two, this one as well as this one, they're going in different directions. So the answer is supposed to be 40, but they use the same direction. Possibly they were assuming it's going this direction, but then it's just a point here too we must take note of. And then twenda ku example number 3, and then the example number 3 runs is a box with a mass of what? 5. So the mass yedu is equals to what? 5 kgs, isn't it? Here 5 kgs kudaro, if the is pushed on a floor as shown below, isn't it? So if it is pushed on a floor with that, we have to understand that kunokukune a frictional force that is against it, which is coming with 12 newtons, and then the other one is what? 20. So we are going to experience a resultant of what? 20 minus 12, that's what? That's 8 newtons. Is that okay? So resultant force here do E, do F, and we also have what? The mass. So we can be able to find acceleration, and so acceleration, tinenge acceleration yedu is equals to what? F over what? F m, and being given that F here is what? 8 all over the m here is what? 5, and then we obtain what? 1.6 meters per second squared, and we also go to example number 4. Then for example number 4, the maximum acceleration of an empty track of mass P is what? Is 6 meters per second, and so that's the maximum acceleration of an empty track, and then as what is the maximum force produced by an engine in terms of what? P, and so isusu tatoudzwa nzi mass yedu is equals to what? P, and then tobva acceleration yedu is equals to what? 6, and so which means we are able to calculate the maximum what? Force, and so maximum force tinoita kuti F is equals to what? M what? A, which is equal to mass yedu it's what? P, so it will be P multiplied by acceleration due to gravity yedu it's what? 6, and therefore we obtain what? 6 P. So this one would be 6 what? P, and then 6 P or newtons, and then answer by using the result in A, calculate the acceleration of the track when it carries a load half of its what? Mass, and so this track is carrying what? A load, but then the load that is carrying, that's the mass. The mass is supposed to be half of its what? Of its track. Are we together? Saka tirikuti tine track yedu yakadai, so anditi say tine track yedu this one is our track, right? Then track yedu yagara itori ne mass yayo, and the mass yayo ndo yange chitaronza, the mass of an empty track is what? Mass what? P. Saka EP ndo mass yayo, anditi then yevazonza load yazotakurwa iyi yataisa muwe, it's half of its what? Mass, so it will be inengeri half of what? P, and so at the end of the day, the mass here say chine load yacho chine say it will be what? It will be P plus what? Half of what? P. Is that okay? Are we together? So if this thing is going to experience any force, its total mass will be the one that experiences the force that gets involved within that thing, and it so its total mass will be equal to what? It will be P plus half P. That will be equal to what? 3/2 of what? P. Is that okay? So which means that one will be equivalent to what? To the mass, and it. So that's where pataona panapa taiswa mass yedu irichi 3/2 what? P, and it. Tobva tanzi calculate the acceleration, and it test. Saka kuti to calculate acceleration yedu, we also require to have what? To have a force, and it. Saka hanzi using the result in what? In A. In A it calculated the what? The force, and it. So the force yedu up it was what? 6p. That was equal to the what? To the force, and it. Then E it's equal to what? Mass, and it. Saka isusu kana takutsvaga acceleration takuti acceleration is equals to what? Is equals to force over what? Mass, and it, which is the same as the force here, that's what? 6 what? P, and it, all over what? E atinayo, which is what? 3/2 of what? Of P, and it. Then tadaro we find out these two, they cancel out each other, and it. Saka takuchiti E yakuchibva ita 6 multiplied by what? 2 over what? 3, and it. Then this into this one, this into this, it's what? 2 by 2, that gives us what? 4, and it. That's why isusu it come up with what? 4 meters per second squared. Is that okay? So now we have a summary. Kuti pama balanced forces edu, the biggest thing that we have to know is that they have a what? Acceleration of 0, and it. So the object here, it may either be stationary or it may move with a constant speed. Then for unbalanced forces, the object has a what? Has an acceleration. So the acceleration is not equal to what? 0. So it can either have what? Deceleration or what? Acceleration, and it. And then what happens is that the acceleration is affected by what? By the mass of the object, as well as what? The resultant force of the object. Is that okay? So then we'll then look at the revision, but remember that zvese zvatiri kuita zviri kubva paaspect yema-balanced forces and unbalanced forces, and knowing that only the unbalanced forces are the ones that are producing what? They are producing a resultant force, and it. Remember Newton's first law of motion iri kutaura nezveinertia, and it. And then the second law of motion is talking about what? It's talking about what? Force equals to mass. It's talking about force is equals to what? Mass times acceleration, and it. So we'll go to the next topic where we'll also continue on that.